Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 5.3.2. Problem number 10 involves the spinner at the right. And you see it's broken up into 3 equal parts. So the probability of getting the purple, the green, and the black, or any of them, is a 1/3 probability for each individual spin. So it says make a table and calculate the probability of each of the following outcomes. Getting a black twice. So it would have to be black and black, right? So if you set up the table, your first event is listed across the top. The first spin, you could get either a, purple, green, or black. And then the second event is the second spin, which you could also get purple, green, or black. So you see there's a total of 9 possible combinations there that you could get. How many of those are black and then black again? That would only be one of them. And so basically what we're talking about here is whenever you are finding the probability of one thing and another thing happening, you will stop. You will take, let me actually do this, 1/3 is the probability of getting a black, and 1/3 of getting a black again. 1/3 times 1/3 is 1/9. What's the probability of getting a green twice? Well, same exact thing, right? You're using the word and, so you're going to take the probability of getting a green, which is a 1/3 probability, times a 1/3 probability. Getting a green twice, there's only 1 out of the 9 in that table that are green. So the answer is 1/9. The local theater is raising ticket prices 20% or by 20%. Assuming the current youth ticket price is $7.50, use the diagram at the right to find out how much more youth tickets will cost. All right, so this is, I talked about this once before, and I just kind of want to go back to it right now. We are going to use this, but I want to use it in conjunction with what I've taught you in the past. Remember when I said that if you can find 10% of any number, if you can find half of any number, or if you can double any number, you can solve a lot of these problems relatively easily, right? So whenever you find 10% of a number, it's just moving the decimal 1 place to the left. So 10% of $7.50 would be 75 cents. Okay, and that's the number that we got right there. It's not listed in there, but that would be the 10% interval, then 20, then 30, then 40, 50, and so on and so forth. So now that we know that 10%, didn't I just have, there it is. Now that we know that 10% is 75 cents, then we can figure out what 20% would be. That would be doubling the 10%, right? Because 2 times 10 is 20, so double that, and you would get $1.50. So that would be the number that you would get here. So how do we know for a fact that it's going to cost $1.50 more? How do we know that 20% of $7.50 is in fact $1.50? Well, let's continue with this counting sequence. So if 20% is $1.50, then 40% must be $3, right? And 60% would be $4.50. And if you double the 40% to get 80%, you double the $3 to get $6, which is $1.50 more. When every time you add 20%, you're adding another $1.50. And so is $1.50 plus $6 equal to $7.50? Yes, it is. So that confirms that 20% of $7.50 is going to be $1.50. Now, let's solve it another way. Remember, $7.50 is the total, and we're trying to find the part. And we're trying to find out what is 20%. So we're going to write that as 20 over 100. Remember, we can cross multiply, and you get 20 times 750. Let's use our calculator for that. 20 times $7.50 is 150. So it's going to be 150. Stop. It's going to say 150 has to be equal to 100x. So when we divide both sides by 100, 150 divided by 100 should give us whatever 20% is. 150 divided by 100 is 1.5. 150. That's what we said it was right there. That's what we said it was right there. So 3 different ways to find what 20% of $7.50 is using a diagram, using proportional reasoning, or using a little bit of mental strategies and logic. Okay. Now, what will the new price be? Well, the original price was $7.50, but you're going to add or increase it by $1.50. So you're going to add those two together, and you get $9 for your answer. All right, another PEMDAS type of problem. Solving numerical expressions using the order of operations. We start with parentheses, then go to exponent, then do multiplication or division, and finish it all up with addition or subtraction. Now, I want you to notice something here. You notice how all of these numbers are repeated, but the operations changes, right? So we still have multiplication, we still have addition, we're still taking the 2 and the 3, there's the 2 and the 3. We're moving, I guess we're changing the exponent here a little bit compared to there, but for the most part, they're the same numbers, just done in a different order. So let's go ahead and work through this process. Start with the parentheses, so this becomes 6 plus 4 times 5 squared. Then go to the exponent. 5 squared is 25, so we'll multiply that times 4 to give us 100, and then eventually we just add the two numbers together. So all of this is equal to 100. 6 plus 100 is 106. There's our answer. Here we do the parentheses first, so this becomes 10 times 5, which is how we get 50 for our answer. That was a little bit easier than that one. And in this one, we have to do the exponent first because there are no parentheses. So this becomes 6 plus 4, and then 2 to the third power. Sometimes people accidentally call it 6, but 2 to the third power literally means 2 times 2 times 2. So that is 4 times 2 is 8 plus 3. Now, the second most common mistake is people get 50 for this answer because they accidentally add first before multiplying. But we don't want to add first, we want to multiply first. The reason why we added first here is because the parentheses gave this the higher priority. So we don't want to have addition as the higher priority. We want multiplication to have its normal priority. So this becomes 6 plus 32 plus 3. 6 plus 32 is 38, and 38 plus 3 is 41. So our final answer here is 41. And problem number 113, write the expression as shown on the expression maps. Okay, so the reason why we're working with this now is because we really, when we get to the 5D process, we want to be able to solve those problems algebraically. And so let's not forget our algebraic processes here. First of all, combining like terms. When you add like terms together, they have to be the same type of term, right? So we can combine these x's together, and we can combine those ones together, but we're not going to combine the x's and the ones other than to just say the final answer is either negative x plus a negative 1 or negative x minus 1. Remember, we cancel out the 0 pairs here, leaving you with 1 negative x and 1 negative 1. Here you got 2 x's and a negative x, so the x and the negative x cancel out to make that just 1x. The x squared has no one to combine with, so it's going to stay as x squared, and then the 1 and the negative 1 cancel each other out, so we end up with a final answer of x squared plus x. And now this should be the last problem. Look at the algebra tile shape at the right. Write an algebraic expression for perimeter, and it says in 2 ways. First, by finding the length of each of the sides and adding them together, and then by writing the simplified expression. All right, I didn't do it. Sorry. But what they wanted you to do is say x plus x minus 2 plus 1 plus 1 plus x minus 1 plus 1 plus x plus x plus x. But it seems so much easier to take all of your x's and combine them. You got a total of 1, 2, 3, 4, 5, 6 x's right there. And then take your negative 2, cancels out with those positive 2's, and your negative 1 cancels out with that positive 1, so it ends up being 0. So 6 x's plus 0, the perimeter is 6 x's. Now write an expression for the area. Well, the area is straightforward. You got an x squared there, you got an x here, and you got a 1 here. So the names of the tiles are the areas of the tiles. And so the area of the entire shape would be this area plus that area plus that area, x squared plus x plus 1. And that is it for our homework. Hooray. All right, let's move on to the next activity, which might just be an assessment. We'll see. Take care. Bye.
Hey, feeling good.